This is part 5 of section 6.3 and the final part. So the number e is a mathematical constant, and it's defined as the limit as n approaches infinity of 1 plus 1 over n whole thing raised to the nth power. Fortunately, we have a button on your calculator for that, so you can use your calculator to calculate it to 9 decimal places, and you should get 2.718281828. Now, e is an irrational number, meaning it cannot be represented by a fraction. I know that it looks like that it starts to repeat 1828, 1828, but it doesn't. So further out here, it stops repeating. So it cannot be a rational number. Okay? The graph of e to the x is just like our regular exponential functions. So if e is the a, the base, the growth factor, and x is the exponent, we have exactly the same thing as we have for all the other exponential functions. We have the point -2, 1 over e squared, -1, 1 over e, 0, 1, 1e, and 2e squared. So moving on to the next page, we can solve exponential equations. So if we have 5 to the x plus 3 equals 1 over 5, that's a little bit harder to solve than what we've doing before. Why? Well, because the exponent, well, the variable is in the exponent, right? That's okay, because if a to the u equals a to the v, in other words, if the bases are the same but the exponents are different, then the exponents have to equal each other. So all we have to do to solve these is get the same base with different exponents. So this one up here is 5x plus 3, and using the rules of exponents, 1/5 is 5 to the -1. So since the bases are the same, we just have to set the exponents equal. So x plus 3 equals -1 and solve. So x equals -4. So let's practice. So we have 2 to the 3x minus 1 equals, now 32 is 2 to the 5th. How could you decide that? Well, just take 32 and start dividing it by 2, because we know our base is 2. And if we do that, to get to 1, we have to divide it by 2 5 times. So that means that 3x minus 1 equals 5. So 3x equals 6. So x equals 2. And that's all there is to it. So on B, well, our bases are already the same, so there's nothing to even solve here. We know x is -6. On part C, we have 4 to the 2x minus 5. 1 over 16 is 1 over 4 squared, which means it's 4 to the -2. So 2x minus 5 equals -2. 2x equals 3, so x is 3/2. And on part D, we have 2 to the 2x minus 1. 4 is 2 squared. So 2x minus 1 equals 2. 2x equals 3. Or x equals 3 halves again. Alright, moving on to the final page of 6.3. It's just more solving. So we have 5 to the x squared plus 8 equals 125 is 5 cubed. So that's 5 cubed to the 2x, which means we have 5 to the x squared plus 8 equals 5. Using the rules of exponents, we multiply. So 3 times 2x is 6x. So we have x squared plus 8 equals 6x. This is quadratic, so we need to get all the terms on one side equal to 0. And now we just factor. So x minus 4 times x minus 2 equals 0. So x equals 4 or x equals 2. Now we should check those and make sure that it works, and they do. Okay, on this one, we need everything it looks like in base 3. So 9 is 3 squared, and that's raised to the 2x, times 27 is 3 cubed, and that's raised to the x squared, and that all equals 3 to the negative 1. So we have 3 to the 4x times 3 to the 3x squared equals 3 to the negative 1. Now applying the rule where we have same bases with different exponents multiplied, that's 3 to the 3x squared plus 4x equals 3 to the minus 1. So 3x squared plus 4x plus 1 equals 0. Factoring 3x plus 1 times x plus 1 equals 0. So 3x plus 1 equals 0, or x plus 1 equals 0. So 3x equals negative 1. So x is either negative 1/3 or x is negative 1. And again, you should check those, but they will work out. Okay, if you see an e, don't panic. It works the same way, just our base is e. So we have e to the 2x minus 1 equals e to the negative 3x times e to the negative 4x. That's e to the 2x minus 1 equals e to the negative 3x plus negative 4x. So that means 2x minus 1 equals negative 3x plus a negative, a negative 3x plus a negative 4x is a negative 7x. And now we just solve like normal. So we have 9x equals 1, so x equals 1/9. Again, check to make sure that it works in the original equation. It does. Okay. Looks like we need base 2 this time. So 1/2 is 2 to the negative 1 to the x minus 5. 8 is 2 cubed to the x times 2 to the x squared. So applying the rules of exponents, we have negative 1 times the quantity x minus 5 equals 3x plus x squared. And I skipped a couple steps in there. I suppose I should show you. So this side breaks down to 2 to the 3x plus x squared. And then that side stays 2 to the negative 1 times x minus 5. Okay, so we have negative x plus 5 equals 3x plus x squared. So get everything on the same side equals 0. We have x squared plus 4x minus 5 equals 0. So 0 equals x plus 5, x minus 1, so x equals negative 5 or 1. And again, check those, but they work out.